Hello, everyone. My name is David, and I want to thank you for everyone for coming to this presentation, in which my mate Gabriel and me will be talking about blockchain and a specific use case that we could see that this application, this technology could have in the future. This is the agenda for the presentation. First, I will be introducing the blockchain and some of its properties and features. And then Gabriel will talk about this application that, in this case, is used to certify the assistance to an event using the blockchain technology. But first, what is blockchain? Blockchain can be defined as a database, a digital database or ledger, that is distributed among the nodes of a peer-to-peer network. Each of the nodes of, well, the data structure behind this database is a linked list in which each of the nodes of the chain contains a link to the previous block in the chain and also a list of all the transactions that happen in the network after the creation of the previous node. This architecture provides a secure, transparent, and unchangeable record of all these transactions. Beyond digital currency, this technology can also be used, for example, to prove the ownership of an asset or also the authorship of a piece of work. But okay, how are these unchangeable security and transparency properties achieved? That is why we need to introduce the concepts of immutability and also decentralization. And then we will talk about how the smart contracts come into play. As we said before, the blockchain, it's a peer-to-peer network in which each of the nodes contain a copy of all the blocks in the chain. This avoids the problem of having a single point of failure, and also controls that there's a single entity that has power over the network. Okay, and that is what we call decentralization. Okay. Also, all the nodes in this network needs to follow a consensus mechanism, which is used to validate the transactions and also verify the integrity of the chain. This consensus mechanism is a set of rules that each node needs to follow to ensure to validate the transactions and also find the new identifier for the new block that needs to be added to the chain. This consensus mechanism can be proof of work or proof of stake. In the proof of work algorithm paradigm, a set of miners compete to find the new hash ID for the new block that will be added to the chain. The network will set a set of conditions that this new hash ID needs to comply with, and then the miners will iterate over a specific field in the header to find a new hash ID that complies, that adheres to these conditions that the network set. Once the miner finds this new hash ID, it is sent to all the other nodes in the network, and if they validate it, the network will award the miner that found the hash ID with the currency of the blockchain. But this proves to be we need a heavy compute load to find this new hash ID. And this proves to be very energy inefficient. So the Ethereum network proposed a new way of working with the proof of stake paradigm. In this case, the node that will compute the hash ID for the new node, for the new block, is pseudo-randomly chosen among all the other nodes in the network based on the stake currency that each node has. Once this node that is selected propose the new hash ID for the new block, all the other nodes need to also validate that the contents of the block are correct. And in this case, instead of receiving directly a currency award, the node will be awarded with transaction fees of future transactions in the network. Okay, but how does these mechanisms and properties ensure that the network is unchangeable? The key to this resides in the structure of the block itself. As we said before, the node has an identifier to the previous block in the chain, and also the complete list of transactions that need to be stored. However, this is not the only information that is stored in each block, and there are also two more relevant fields that we want to mention. The first one is the nonce, or non-repeatable number, which is the number or the field that the miners need to iterate over in order to find the new hash ID that complies with the condition that the network set. And the other one is the Merkle hash. The Merkle tree is a data structure that is similar to a binary tree, in which each of the leaves of the node of the tree, it's a hash of a data block. And in this case, the data blocks that are hashed are the transactions that will be stored in the block. The other nodes that are not the leaves are a composition of a hash of the composition of both of their children. This composition leaves us with a node in the top, in the root, that it's a hash that holds the information of all the nodes in the block. This allows us to quickly and easily verify that the contents of the block are legitimate, because any change in any part of the data of any of the transactions that are to be stored will result in a completely different hash. This is also used by all other nodes in the network to validate that the contents of the block are correct. Before moving into smart contract and the demo of the application, we also wanted to mention how in blockchain, cryptography is also used to provide unique identities for everyone. And also to provide these unique identities with different derivative addresses that can be considered like different account numbers that a person could have. This is also used in software and hardware wallets to ensure security. In this case, in blockchain, the blockchain contemplates these problems with the VIP algorithms, specifically the 32, 39, and 44. But the blockchain can be used for more than storing just a record of all the transactions. And a smart contract is a good example of this. The smart contracts are little programs that are executed in the blockchain and can be triggered both manually or automatically based on different conditions that we set previously. They run in the Ethereum virtual machine, or EVM, and are written in Solidity. And following this concept, we have the blockchain tokens, which are just the product of smart contracts that follow a specific technical and a specific standard that is written in technical documents called Ethereum request for comment. These smart contracts that follow those standards provide different functionalities, such as getting the balance of an account or transferring funds. And depending on the character of the token that we want to produce, we have different standards, such as the ERC20 for fungible tokens, which are just the currencies, and also the ERC721 for non-fungible tokens or NFTs. And now
And now what I'm going to explain is a real case and a real application, and how to develop and deploy an NFT in a real network. But we are going to do these use cases in a context of a smart city. And in this smart city, we have citizens. So the citizens will be identified in the blockchain and in the city with a unique identity. That's one of the main points that the blockchain could help us to organize the cities. In the city, we have different sectors. So with this unique identity, we could interact with the health system, with the transport, or even with the education. And the use case that we are going to see here is about the education. The idea is to represent the university certificate instead of a physical asset. We are going to move this physical asset to the blockchain, to a digital copy or representation of this asset using the standard NFT. Then, when the NFT is being written in Solidity in the smart contract, we are going to deploy into the blockchain. And once this smart contract is deployed in the blockchain, we could use it. And we are going to use it to assign the certificates for Alice, for example. And once Alice has the certificate, we could validate the ownership of this certificate by Alice. And this is what we are going to do. Which is our development environment? Looks like this. We have two different pieces of code. One code written in TypeScript is an standard application as a desktop app, mobile app, or a web app. And then we have the Solidity code. The Solidity is the smart contract itself, is the NFT, is where we are going to program the certificate. Then these pieces of code is going to be copied inside a container, and this container includes a hard hat framework. The hard hat framework helps us to build, test, and deploy the smart contract in the blockchains. Also includes the compiler for Solidity programming language and libraries to use HTTP protocol or RPC. And also, I've installed the CLI command interface for Avalanche, and we could interact with the Avalanche network. So, the project, we have this tree. We have the source folder, and then inside the folder, we have three other folders: the contracts, the main, and the titles folder. In the contract folder, we have all the code written in Solidity. In this case, we only have one contract. In the main one, we have all the code written in TypeScript. It's a standard application. And then in titles, we have the images that will represent our certificates. And then we have one important file, hardhat config.ts. This file is where we can define our networks. We could have a local network. For example, in Worldline, we could create a custom blockchain network for Avalanche and run this network in our local machines. Or we could use the official one. In case of Fuji, is the testnet of Avalanche, the official testnet network, or the main one. Okay, and now I'm going to show you which is the certificate that I've written to do this presentation. The contract is the first word that we see. We are defining a contract. Then follows the name of the contract, Worldline third. And we are saying to the contract which is the standard that we want to use. In this case, the NFT standard. Then we have other words that are important. For example, the variable type address. The address represents the wallet that is deploying the contract in the blockchain, or the address that is using the contract once this contract is deployed. In this case, the variable, the name of the variable is owner, so it's the person who deployed the smart contract in the blockchain. Then we have the function constructor. The constructor function is called only one time when the smart contract is deployed. And what we are doing here in the constructor, we are assigning into the variable owner the address of the person who is deploying the contract. In our use case, which is the person? It's not a person, it's an organization. Will be, for example, Worldline, because Worldline is the one who wants to create a certificate. And then we have two functions, the base URI, which returns a string, which is the URL with an important field, the hash of Pinata, that we will talk about Pinata later. And then the SafeMine. The SafeMine is the function to assign certificates for someone. The SafeMine function has another important word in Solidity, is required. Required is like a restriction. With this word, we are restricting who can use this function. In this case, only the owner of the contract, only the person, or in this case, the organization, who deploy the smart contract into the blockchain can assign, in this case, certificates to someone. And now I'm going to show you a little demo about how to create all the accounts that we are going to do, we are going to use later in other demos. Now we can see 4 accounts. The Worldline account that has already the seed, the 24 words, and 3 other users, Gabriel, Daniel, and David. This will be the person who is going to receive the certificate. With this application is the core wallet, is the official wallet for Avalanche. We can create the seeds for these users. And with this seed, we could calculate later the address and the public key and the private key of the user. Now, we are going to run a standard application written in TypeScript or in JavaScript. That does not make sense. And this app will read from the JSON the seeds of Gabriel, David, and Daniel, and will calculate the private key and the address. With the private key, we could open it, the wallet, and interact with the blockchain. And now we are going to copy and paste the address into the JSON, because this JSON will be used later in other applications. Okay, now we have everything configured, and we need to do another step. We need to open the wallet. How? We are going to take the seed or the 24 words of Worldline, for example, and we are paste it into the core wallet. Filling all the spaces in the form and finishing the process, we will be able to use the blockchain Avalanche. Okay, now Worldline is connected to the blockchain Avalanche. So we can see, and what we are going to do. In this case, we want to use the wallet in the testnet network of Avalanche. We don't want to use it in the mainnet. And now, for testing, we are going to import the keys of the users, Gabriel, David, and Daniel, in order to see the results of the demo. But in a real scenario, of course, the private key you cannot share with other person. And that's it. We only are importing the uses in our wallet to be used later. Okay, but now what we are going to do? We are going to take this real certificate, or assistant of this tech forum event, for example, and we are going to put this physical asset in a blockchain as an NFT. And the use case that I'm going to show you in the live demo is divided in 2 different flows. The first flow is Bob, or in this case, Worldline, has to create 1 image per certificate per person and 1 metadata per certificate per person. These files will be uploaded to Pinata, and Pinata will provide us a unique URL. With this unique URL, we are going to create the smart contract, deploy the smart contract in the Avalanche, and get the address to use the smart contract. And this is what we are doing in this video. We are using the main application, calling the function generate titles. This function do three actions. Read all the images that are in the folder titles. Create the metadata for one of these pictures, and upload everything to Pinata. Okay, now it's uploading the files to Pinata. The process has finished, and now we have in Pinata. What is Pinata? Pinata is a object storage that uses the protocol IPFS, which is why it's important, this protocol, because with this protocol, we could guarantee the integrity and immutability of all the objects that are being uploaded. As you can see here, we see the folder titles and metadata, and we see the information, in this case, of the metadata file. Also, we can see the ID of the file and the ID of the folder. The ID of the folder is very important because it's the hash that we are going to paste in our smart contract, and then we are going to upload this smart contract or deploy the smart contract to the blockchain. Once the smart contract is deployed, it's totally immutable. We cannot modify this address. It's very important because this address links against the files, the NFTs that we are creating. Now we are deploying with another TypeScript application provided by Hardhat. And well, when the process finishes, we will get the address of the smart contract. Perfect. Now we have the address of the smart contract. What we can do now? Use the smart contract. Or what we are going to do is to see this smart contract in the Block Explorer. Snowtrace is a web page that see the blockchain avalanche, and we can see our smart contract that has been deployed. We can see some information, the address. We see that there are no transactions because the smart contract is deployed but not used, and the binary of the smart contract. Okay, now we have our smart contract deployed. We have the address of the smart contract. We can use it. What we are going to do? Assign the certificate to Alice, or in this case, the certificate to Gabriel, Daniel, and David. How? Calling the function SafeMine, and is what we are going to see in this video. Again, we are running the main TypeScript application. And we are calling the function SafeMine, as you can see. This is a JSON with all the assistance to detect forum event in this case. And when we run the app, okay, the app asks the ID of the person who is going to assign the certificate. In this case, we have choose Daniel, but we have an error. The SignNet cannot perform this action. Only Worldline can do it. Remember, we had a required restriction. Only the Worldline wallet can create the certificate. And it's what we are going to do now. We are going to run, again, the same app, but in this case, we are going to use the seed of Worldline. So now with the Worldline account, we are able to assign the certificate. In this case, we are going to assign the certificate of the Gabriel's user. Okay, now the process has finished, and if we refresh the Snowtrace web, we can see the transaction of the creation of the token. Of course, in the wallet of Gabriel, in the core app wallet, we can see the NFT that we have created. And if in the Block Explorer, we can see all the information of this token, this NFT that we have deployed. And now what we are doing is the same, but in this case, we are deploying, we are assigning the certificate of the other two users, David and Daniel. It's the same process. Perfect. We can see two new transactions, two new tokens are assigned. And if, again, we go to our core wallet, and change the user to Daniel. In the NFT section, we see the NFT assigned to the Daniel's account. And the same for David. So, which is our conclusion? With blockchain, we could create application totally decentralized with unique identities for different industries, different sectors, different goals. We can digitalize physical assets, and also we can guarantee the immutability of all the information that is registered in the distributed database, which is the blockchain. And that's everything. Thank you.